Okay, today we're going to talk about something that we haven't seen before, something called an algebraic fraction. And we're going to cover three integrated algebra standards. First, the standard we're going to cover is AA14, which is divide a polynomial by a monomial, where the quotient has no remainder. In AA15, find values of a variable for which an algebraic fraction is defined. So we're sort of explicitly covering this one. In the lesson today. AA14, we're going to simplify a polynomial, and I'll show you when we cover that. In AA16, we're going to simplify fractions with polynomials in numerator and denominator by factoring both and renaming them to lowest terms. So simplifying fractions with polynomials in the numerator and denominator, that's what an algebraic fraction is. And we're going to use the method of factoring. And then we're going to cancel any common factors. Okay, so our lesson objective today is what is an algebraic fraction, and also how do we reduce an algebraic fraction. So all vocabulary is algebraic fraction. And to go right into the definition, an algebraic fraction is the quotient of two algebraic expressions. So remember, algebraic expressions are anything involving a constant or a constant plus a variable, and the variable can be raised to different powers. So in the first example, this x over 2, it's the x is the variable and the 2 is the constant. So an algebraic fraction is different from an arithmetic fraction, because an arithmetic fraction is the ratio of two integers. Okay, an algebraic fraction says that either one of those have a either the numerator or the denominator has a variable in it. So you could have x over 2, or like you could have 2 over x. So this is another example, this one. In the next one, we have x plus 5 over x minus 2. Those are both, you have a binomial in this one, and a binomial in, you have a binomial in the numerator, and you have a binomial in the denominator. In 4c over 3d, we can have variables that are not x's there. And finally, in this last one, x squared plus 4x plus 3 over x plus 1, we have a trinomial on the bottom, and we have a binomial on the, we have a trinomial on the top and a binomial on the bottom in the denominator. Okay, so that's the definition of algebraic fractions. Now, algebraic fractions are, for the most part, going to act a lot like algebraic expressions, with one huge difference. Okay, algebraic fractions are defined for any value of x, except values of x that make the denominator 0. Okay, so remember, anything, you can have 0 divided by any number is 0, but any number divided by 0 is undefined. So you can never, in algebra, you can never, and in math, you can never divide by 0. So anything that's going to make the denominator 0 is going to be eliminated from the domain. Remember, the domain is any value of x that you want to put into the algebraic fraction, or the algebraic expression. So the algebraic fraction x over 2, there's nothing, the 2 is in the denominator, so there's nothing that you can put in the denominator to make that 0. So there's no undefined values. So the domain for that expression, I'm allowed to put anything into that expression. So that's all real numbers. So x can be all real numbers for this one. Now this next algebraic fraction, 2 over x, you're not allowed to put in the value of 0. So x cannot, and I didn't mean to put an x here, so there's no undefined values for the first one. So in the second algebraic fraction, 2 over x, you're not allowed to put the value in of 0, because if you did, you'd have 2 over 0, and that's not allowed. Okay, so for the domain, it's all real numbers except for 0. Whoops. All real numbers except 0. Okay. Now, in the next one, x plus 5 over x minus 2, 0 is not going to make the denominator 0. So if I put 0 in for both the x on top and the x on bottom, I'd have 5 over negative 2, and that's not a problem. That's just negative 2.5. But you have to look at the expression at the bottom. So take the expression out of the bottom, x minus 2, and set that equal to 0 to ask yourself, what's going to make this 0? So you're going to solve this little equation here. x, and it turns out x is 2, is going to make that 0. So you are not allowed, x cannot be equal to 2. You're not allowed to put 2 in, because if you put 2 into that x right there, if I put 2 in the numerator, by the way, it wouldn't, so let's say that I replace 2 in the numerator with x, I'm sorry, x in the numerator with 2 and x in the denominator with 2, the numerator would be okay, it would be 7, but the denominator would be 0, and so then you're left with something that's undefined. So x can't be 2, and so we say it's all real numbers, the domain is all real numbers except 2. Oops. Okay, so the second algebraic fraction, 2 over x, was okay for every value except 0, and the third one is okay for every value, including 0, except for 2. Now, this bottom one, we're going to look again at whatever makes this 0. So we're interested in the value that makes that 0. If we solve this little equation here, okay, we'd say that if I put in -1, if I substituted -1 in here for x, that's going to make the denominator 0. So that's what we cannot allow. So x cannot be -1. So we have all real numbers except -1. Those are what's allowed. Okay. So remember, that was one of our values here. One of our things that we're looking at. We're trying to find values of a variable for which an algebraic fraction is undefined. And so that's what we're doing in this slide right here. Okay, the next thing that you need to know how to do is you need to know how to simplify algebraic fractions. So let's review our rules of simplification. First of all, a fraction is considered in its lowest term if the numerator and denominator share no common factor other than 1 and -1. So for instance, if I have an arithmetic fraction, 2/3, that's simplified because 2 and 3 do not share a common factor other than 1. Or -2 and 3, those only share a factor of both 1 and -1, actually. Now, something like 4 over 6, however, would share a factor of 2. So I can rewrite 4 as 2 times 2, and I can rewrite 6 as 2 times 3, and here I can cancel out that 2 over 2. Because remember, that's, well, the worked out solution would be, I can rewrite this as 2 over 2 times 2 over 3, but 2 over 2 is just 1. So I'd be left with 1 times 2 over 3, which is just 2 over 3. That's why you're allowed to cancel, okay, because that becomes a 1. So basically, you're eliminating any factors that are the same in the numerator and the denominator, okay? So the first thing you want to do, the first step, is you want to factor both the numerator and denominator, like we did with the 4 over 6, and then divide both the numerator and denominator by the greatest common factor. Okay, so let's review some factoring rules. Now, 3a over a squared, this is something that we can factor because 3a means 3 times a, and a squared means a times a. And so here I have my 1, so I can cancel that. I can divide the numerator and denominator both by a, and I would get 3 over a. Now, 3 plus a and a plus 1, a very common mistake, and you do not want to do this, is to say, oh, well, a is in the numerator and a is in the denominator, so I can just cancel them. And the reason why you can't do that is because the a is being attached to the 3 with addition, not with multiplication. So these a's are not being attached with multiplication, so you can't just cancel them like this. This is not allowed. So for instance, if this is the same with an arithmetic fraction, if you said like 5 over 9, you said, well, 5 is just 1 plus 4. And then, 9 is just 5 plus 4. And then, oh, I have a 4 in a numerator and denominator, that's just 1/5. But look at what you've done here. You said that 5 over 9 is the same as 1 over 5. Okay, 5 over 9 is greater than a half because 4.5 over 9 would be a half. Whereas 1/5, that's not even close to a half. So you have done something, you canceled in the incorrect way, and you got something that wasn't an equivalent fraction in the end. So do not make the mistake of canceling when there's addition. These are not factors, these are add-ins. You're allowed to cancel common factors. You can't cancel common add-ins. Okay, so let's go through some of our examples here. 15x squared over 35x to the 4th. So remember 15, let's think about the GCF between 15 and 35. that's going to be, let's see, 15 is 5 and 3, so the GCF is going to be 5. So I'm going to rewrite this as 5 times 3 times, and x squared, and in the bottom, x to the fourth can be broken down into x squared and x squared, okay? And 35 can be broken down into 7 times 5. So let's cancel what we have. We have a 5 and a 5, both in the numerator and denominator, x squared and x squared, and then let's rewrite what we have. In the numerator, we have 3. In the denominator, we have 7 times x squared, so we have 7x squared. Okay. Now, is this in the lowest terms? Well, 3 and 7, the GCF between 3 and 7 is 1. And there's nothing else to cancel with the variable term. So this is in its lowest term. Okay. The next one has a binomial on top and a monomial on the bottom. So if you recall, you can factor, what you want to do is you want to factor the top. Now when you factor a binomial, you first ask if it's a difference of squares. And so for our case, it is not. So I factor the GCF from 2 and 6, which is 2. And the GCF between x squared and x is x. And I rewrite the remaining terms. I have an x inside minus 3. Okay, and on the bottom I have 10x. So I'm going to rewrite 10x as 5x times, I'm going to rewrite it as 2x times 5. Okay, notice how if I multiply those back, I'd get 10x. Well, now I can just cancel, right? 2x over 2x cancels. And what do I have left on top? I have x minus 3, and I don't need the parentheses there because nothing's being multiplied by it, over 5. And that is as simplified as it gets. Okay, let's try another one. So on the top of this one, you have to really recall your factoring rules for your polynomials. On the top you have a difference of squares, so you factor that into the sum and difference of two terms. On the bottom you have a trinomial, so I'm going to use the x factor to factor it. I have a negative 5 up here and 4. I'm looking for two factors that multiply to 4 and add to negative 5, and that's going to be negative 4 and negative 1. So on the bottom I'm going to have x minus 4 and x minus 1. Now the top has two factors in it, and the bottom has two factors in it. So if I wanted to, and you don't need to show this level of work, but let me just show you what I can do here. I can rewrite that, the top, as those two factors in that order because multiplication is commutative. I can rewrite the bottom like this, and all of a sudden I have these x minus 4s that are a factor in both the top and the bottom. So the numerator, what I have left is just x plus 4, and again I don't need the parentheses because there's nothing being multiplied by it. In the denominator I have x minus 1. And that is as simplified as it gets. Now do not make the mistake where you say, oh, there are x's here, so I can just cancel the x's. No, you can't do that because then you'd have 4 over negative 1, which is 4, or negative 4, and that is not equivalent to having two algebraic expressions in the numerator and denominator. This is as far as it goes. You cannot cancel the x's. Okay, in this next one, there's a little trick to this one. And again, we can't just say this cancels with this and that's equal to 1 because that's not true. The numerator and denominator do not look the same because, first of all, this is the minuend and this is the subtrahend in the numerator, and x is the minuend and 3 is the subtrahend in the denominator. But there is this little trick that you can do, which is to say that if you want to make the numerator look like the denominator, you can factor out a negative 1. So if I factor out a negative 1, 3 becomes negative 3. Well, let me just do it this way first. If you want to divide, rewrite, let's just rewrite this with addition first. So let's leave this as 3 plus negative x and x plus negative 3. Okay, so the problem is the negative is on the x in the numerator and the negative is on the 3 in the denominator. So you can factor out a negative 1. So this is the trick. So if you factor out a negative 1, 3 becomes negative 3 because if you multiplied those back again, you'd get 3. And if you factor out a negative 1 for x, you would get positive x. Again, if you doubt what I'm saying here, you can always multiply through to get back 3 plus negative x. Then the bottom would be I can commute these two because now it's addition, so I'd have negative 3 plus x on the bottom. Now, the numerator and the denominator are identical, so they can cancel, so what you have left is negative 1. Okay, so let's just go back to what we have. Anytime you have something in the numerator like a minus b over b minus a, this factors into negative 1 because of this trick. Okay, so just make sure you write this down. This is a general rule. Okay, and finally, if I have 2 minus x and 4x minus 8, again, I want to factor out a negative 1 here, and that is going to flip around my subtraction. And then in the bottom, if I want to factor out a 4, I'd have x minus 2 there. Then I can cancel those out, and what I have left is negative 1 over 4. Okay, so make sure you take the time to go through all of these and make sure they make sense to you, and come to me with questions in the morning if you have any, because these can be a little tricky. You really should review your factoring rules that we learned about earlier in the year for this.